Okay, so the first thing that they ask us to do is a general solution. So we've got tan x equals 2 sine 2x, where cos x is less than 0, and this is for 7 marks. All right, so maybe what I should have done is put our identities onto the screen. I wonder if I've got them down here somewhere. No, okay, that was silly of me when I was putting this slide together for you guys. I forgot to do that. Did we have it here? No, we didn't. Okay, all right, never mind. Hopefully you guys know your identities anyway, so let's just get started. I can always go and grab it just now if somebody's having an issue. So where do we think we should start with this general solution? Swanako, you haven't missed a thing. We're just getting started. We're going to do this question. Okay, so no stress. All right, so what do we think we should do? We've got tan x, and it's equal to 2 sine 2x. What's the first thing you guys want to do? Okay, so Trish says expand the 2x. Okay, so I'll leave tan x as it is for now. And if I've got 2 sine 2x, I've got the 2 on the outside, and sine 2x we all know is 2 sine x cos x, right? So that means that tan x would be equal to 2 times 2 is 4. So that would be 4 sine x cos x. Cool, Trish. So I've done that. What do I do now? What next? Any ideas? Matrix, what should I do next? Right, so maybe we're struggling to answer this because we're not thinking about, okay, all right, iPhone, that's what I was going to say. So remember our grade 11 identities. Okay, so the first identity we learn in grade 11 is our tan identity, and we learn that we can write tan x as sine x over cos x. And incidentally, if it's tan x, it would be sine x over cos x. If it was tan squared x, it would be sine squared x over cos squared x. If it was tan 2x, we would write that as sine 2x over cos 2x. And if they gave us something super weird, which they probably wouldn't do in matric, it's more of a grade 11 thing, but just in case, if they gave us tan 90 plus x, for example, we would then write that, let's just scooch over just a little bit, we would again use our tan identity. So we would write that as sine 90 plus x over cos 90 plus x. Okay, so our tan identity. So quite right, who made that suggestion? Let me just go back and have a look. iPhone, whoever you are, thank you so much. But quite right, we would write tan x as sine x over cos x. So I'm just going to do that now. I'm going to rub this tan x out, and I'm going to write it as sine x over cos x. Cool. Now what do I do? Okay, so Lisejo says cancel cos x on both sides. Am I allowed to do that? Can I cancel over the equal sign? No, unfortunately not. That's not a mathematical rule or a law. I'm not allowed to cancel over an equal sign. I can cancel over multiplication and division, but I can't cancel over an equal sign. So what should I do? Because I'm not allowed to cancel here. Aha, so Sydney says cross multiply. Beautiful, Sydney. Thank you so much. All right, so I want to get rid of that denominator on the left. I don't want the cos x at the bottom. So cross multiplying is the same as multiplying by cos x on both sides. So that leaves us matrix with sine x on the left, and it leaves us with 4 sine x cos squared x on the right. Okay, now again, the question is, what do I do? What's the next step? So all of this is my algebra. Okay, this is not trigs, strictly speaking. This is algebra. So the manipulation of the equation is algebra. What should I do next? Okay, and Canyiso says change cos squared x to 1 minus sine squared x is one suggestion. Okay, good. I'm so glad you said that, Jamie. All right, because that is unfortunately what you cannot do. Okay, now why can we not divide by sine x? Number one, you cannot divide by sine x because it's not an identity, it's not a thing. Okay, we can divide sine x by cos x because sine x divided by cos x is an identity. But I can't divide by sine x because it's not a mathematical rule or a law. Also, I would end up losing a solution. So Jamie, if I had an equation like this, I'm just going to do this on the side. Imagine I had x squared equals 3x. Can I divide by x on both sides? Can I divide this side by x and that side by x? Is that allowed mathematically? Can I do that? I'm so glad you said this, Jamie. It's a wonderful discussion point. Thank you so much. No. All right. It's not allowed on a number of reasons. Okay. Number one, what if x is equal to 0? Then what I'm dividing by, it would result in a solution that's undefined, for one thing. Second thing is if I divide by x, I'm losing a solution. So if I divide by sine x on both sides, I'm essentially canceling out a solution. So I'm not allowed to do that. Now, I see somebody else while I was busy yabbering away said, take sine to the other side in Canyiso. Yes, yeah, absolutely. So collect all your terms on one side, and then you can factorize. Okay, so 4 sine x cos squared x, and transposing that sine x, I'd get minus sine x on the right. Beautiful. Okay, now what am I going to do? Okay, so it would be the same thing if you had the x squared is equal to 3x, and you took them over to one side and you made it equal to 0. Your next step would be to factorize. There we go. Take sine x as a common factor. Good. Iola, yes, common factor sine x is common. Good. Well done, everybody. Okay, so let's take out sine x. That leaves us with 4 cos squared x minus 1. Okay, good. Well done. Now, what's going to happen? So either sine x is equal to 0, or cos squared x will be equal to 1 over 4. Absolutely. So I can't go anywhere other than to work with the sine x equals 0. But as far as the cos squared x is equal to 1, I'm not solving for cos squared x, I'm solving for cos x. So if cos squared x is equal to 1 over 4, I'm now going to have two solutions for cos x. Okay, so therefore cos x is going to be equal to plus minus the square root of 1 over 4. Okay, so don't forget about the plus minus. So that means that either cos x is going to be equal to 1 over 2, or cos x is going to be equal to negative 1 over 2. Does that make sense to everybody? Everybody happy so far? Any questions? Because now I'm going to go back up to the question, which I know we can't see anymore. Are we all good? All right. Aha. And can you, so that's what I'm saying. Let's go back. All right. But now, obviously, you guys would have this in front of you. It's going to be a bit easier when you've got your page in front of you instead of me going up and down. But look here, they only want us to do the general solution where cos x was negative, where cos x is smaller than 0. So they have placed a restriction on our solution. Okay, so now when we go back down here and we have a look, the only thing they want us to work with is that. They want us to do the solution where cos x was negative. So we're not going to worry about where sine x was 0 and where cos x was equal to 1 over 2. We are only looking at where cos x was equal to negative 1 over 2 because of the restriction in the question. Okay. Our next step, after we have got sine x equals or cos x equals or tan x equals, our next step is to find our reference angle. Some teachers call it a key angle. In previous Watobe lessons, if you've listened to my lessons, I like to call it a positive acute angle, a PAA, but it all means the same thing. A key angle, a reference angle, a positive acute angle, it's all the same thing. We do not use the negative when we are finding our key angle or our PAA. All right, Sihle, what I'm going to do, sorry guys, I've just had a message from Sihle. Yolanda, please can you reach out to Sihle Sakeni? They're just having a little bit of an issue with this question. Could you just reach out and just help them, please?
Yes.
Thank you so much, Sihle. Yolanda is coming to the rescue. Okay, so Iola says, let's just see what you're saying, Iola. You're sending me the PAA or the reference angle. Thank you, Iola. Quite right. Okay, your PAA, reference angle or key angle. You're quite right, Iola, is going to be 60 degrees. Iola, how did you find that reference angle? What did you do on the calculator? Can you tell us? Good. Shift cos, and then you put in the 1 over 2. Brilliant. Okay, so we do not use the negative to find the reference angle. We use the negative to know which quadrants in which to do our general solution. So we're almost there. Okay, so a quick sketch of our cast diagram. In which two quadrants is cos x negative? It is negative in quadrant 2 and also in quadrant 3. So those are the quadrants we need to work in. We're going to apply our reduction formulae. Okay, so x is equal to, in quadrant number 2, 180 minus our PAA plus k times 360. So that means we'd have x is equal to 120 plus k times 360. And the other quadrant, quadrant 3, would be 180 plus. So here we would end up with x is equal to 240. Okay, that's an iPhone. Well done. Okay, so all they wanted from us was the general solutions. So that means we can stop there. They have not asked us to use the general solutions to find solutions in a given interval. So they just wanted the general solution from us. Okay, so that was out of 7 marks. That's an awful lot, isn't it? So let's just go back and identify where those 7 marks would be awarded. So remember, they always give us marks for using an identity. So our sine 2x, our sine double angle, we would get a mark there for sine x over cos x. Swanaka, you've got your hand up. You're welcome to unmute and ask. You're welcome to ask, Swanaka. So quadrants, general solution, 1, 2, 3, 4, 5, 6, maybe for the other general solution. Okay, so a mark on both general solutions, correct quadrants, getting to cos x equals minus 1 over 2. On our factors, don't leave off the equals 0, and then on both identities. Okay, oh, it was by accident. Okay, no problems, Wanaka. Are there any questions? If not, I'm going to move on.
Can you please take screenshots?
Yeah, please take
so
screenshots.
we can go through this. Yeah.
Okay, Jimmy, what's your, yes, go for it, Jimmy. You're welcome to unmute. Just unmute yourself, Jimmy, and then you can talk.
Wait, ma'am,
There we go, I can hear you.
Okay, I want to ask about if you can please explain the end part.
If I can please explain what, Jimmy, sorry?
I think he said the end part.
You mean knowing which quadrants to work in, Jimmy? Is that what you're referring to?
Yeah, I'm sure it's the 180 minus 60 plus 360. Maybe that's the.
Okay, so Jimmy, the question told me I had to work where cos x was negative, right? So that's why I chose this solution where cos x was equal to minus 1 over 2. Because it's negative, I've got to work in the quadrants in which cos x is negative. So you can see here in the black and the orange, I have got my cast diagram. Cos x is negative in quadrants 2 and 3. So that's why my first solution, 180 minus, that's quadrant 2, and 180 plus, my second one, is quadrant 3. So it's 180 minus my PAA or 180 plus my PAA. The former being quadrant 2, the second one being quadrant 3. I hope that helps. Maybe just chat to Jimmy and just see if he's okay. Yolanda? Oh, okay. All right. You happy with that? Okay, cool.
Yeah.
All right, lovely. Okay, so now for a little bit of problem solving. Matrix, I hope now that we're all sufficiently warmed up and our brains are firing at 1,000,000 miles an hour, we can answer this question together. All right, so now we have been given sine P plus sine Q is 7 over 5, and P plus Q is 90. Without using a calculator, determine the value of sine 2P. What do you think, guys? So I'm going to give you a couple minutes to think about this. I'd really love to get some suggestions from you as to where you think we should start. Nope. Sorry, Voloshin. What do you guys think? Where should we start? So Voloshin made a suggestion. Thank you, Voloshin. He said find Q. Unfortunately, that is not correct. What is everybody else thinking? Where should we start? Jimmy, I understand why you're thinking that. You're thinking simultaneous equations, but unfortunately it's not, because it's the sine of P. So we can't sub the sine of P for angle P, because the sine of P is a ratio. It's not an angle. I can understand why you do that in Kaniso, but even though that's true, it's not going to give us a starting place, but I can understand why you would think that. So the clue to this actually lies in what they want. Sine 2p. And this is where we need to know our algebra so very, very well. Oh, okay, Mbalentle. Oh, I wish I'd done this sooner. Well, I'm glad we're doing it now, because then at least before trials, you'll hope, before finals, you'll be prepared. Yeah. So this is a common thing that comes up. Okay. Should I tell you guys? How do you get sine P equals 4/5? Kamogelo, can you tell us? Okay. So I'm going to start by putting the equation sine P plus sine Q is equal to 7/5. And believe it or not, guys, we need to work with this equation, all right? And what we need to do to both sides, I understand why you're doing that. Yes, Trish, there we go. You need to square both sides. Now, you're probably wondering, why do I need to square both sides? And that's why I'm saying the clue is here in the sine 2p. Okay, so Trish, you're quite right. We're going to square both sides of our equation. When we square both sides of our equation, and I'm going to do this the long way so that nobody gets left behind, we'd end up with sine P plus sine Q multiplied by itself, so sine P plus sine Q. And on the right-hand side, we'd end up with 49/25. We're going to do FOIL, and that's going to give us sine squared P, listen to me, sine squared P plus sine P sine Q plus sine P sine Q plus sine squared Q is equal to 49/25. So now when we collect the bits in the middle, we're going to end up with 2 sine P sine Q plus sine squared Q is equal to 49 over 25. Okay. Now, the other thing that they have told us here is that angle P plus angle Q is equal to 90. Why? So I'm stopping with what I've got on the left-hand side, and I'm now looking at angle P plus angle Q is equal to 90. Why do you think they've told us this? Why do you think they've told us that P plus Q is equal to 90? Okay, so okay, maybe I've made this a little bit small. Maybe I should try and make it a little bit bigger. Okay, so Trish is saying cos squared something plus sine squared is 1. Fair enough, absolutely. Sydney's saying in order to substitute Q with 90 minus P, since we want P, we do. We want everything to be in terms of angle P, not an angle Q, so that we can use the reduction formula. All right, so if they've told us that P plus Q is equal to 90, they probably want us to use some kind of co-function, all right? So the idea is, we call that A, B, and C. If we have got sine squared, oopsie, sorry, I've written that in the wrong way, sine squared Q, can we write that in terms of cos? So sine Q is going to be opposite over adjacent. So that would be A over B. Cos P is going to be A over B as well. Does that make sense to everybody? So in this right angle triangle, because P plus Q is 90, I can label this one as P, that one as Q if I'm working in a right angle triangle. Does that make sense to everybody? Swanaka, Yolanda, Swanaka's saying, ma'am, I think there's a problem with my mic. Every time I click it, it says the host has not allowed participants to unmute. Yeah, Swanaka, it shouldn't be like that. You should be able to unmute. Could you maybe just reach out to Swanaka and just see if you can assist?
Yes, Zanaka, just try it one more time. Let me assist you privately. Fine. Yeah.
Hello.
Okay.
Zanak, I think it's you talking, right? Yeah, now we can hear you.
Thank you, ma'am.
Zwanaka, do you want to talk?
Ma'am, I wanted to ask a question about the previous trig.
Okay.
Um, it's possible to be able to scroll up.
What about this question over here?
The previous one, yes, ma'am. I wanted to ask how exactly are we getting 180 minus 60 and 180
Oh, okay.
plus?
So Swanaka, the reason I had 180 minus was because I had to work in quadrants 2 and 3 because my ratio was negative. So if cos x is negative, it would be negative in quadrants 2 and 3. So that's where the 180 minus comes from quadrant 2. The 180 plus is from quadrant 3.
Okay, thank you, ma'am.
All right, no problem. Okay, so back down here. So in orange on the right-hand side here, what I'm trying to show you is that the reason that they gave you P plus Q is equal to 90 is because they want you to see that the sine of Q is the same as the cos of P. Does that make sense to everybody? The sine of Q is the same as the cos of P. Are we cool with that? Yes. So that means that sine squared Q is equal to the same as cos squared P because I'm just squaring both sides. And I'm doing that so that I can rewrite what I've circled in orange here in a different way. So I've now got sine squared P plus 2 sine P sine Q plus sine squared Q, I'm going to rewrite as cos squared P is equal to 49 over 25. Right. And the reason that I am doing this, okay, is because sine squared P, let's just do this on the side, sine squared P plus cos squared P is equal to 1. Okay, so putting these together, I've got sine squared P plus cos squared P. You don't have to do this next step. I'm just doing it for so okay. I didn't say that sine. I didn't say, Jimmy, okay, wait, hold on a second. I didn't say that sine Q was equal to sine P. I said that sine Q was equal to cos P. Okay, so just be careful about that. And I'm doing that. Okay, so just be careful. Lesejo, why am I using cos P? Because I'm going to write sine squared P plus cos squared P as 1. I did. Oh, you mean in the middle here? Oh, okay. All right. Sorry. Yes, I should have done that one. Sorry. Should have done that one as well. Okay. Sorry, I was just doing one at a time. Who was asking? And Caniso, you're quite right. Remember we said that sine Q was equal to cos P. So what I've done is I've just substituted the one. I haven't done the other one yet. So I've written sine squared Q as cos squared P. What you are referring to is this one over here as well, isn't it? Okay, so I'm going to do that one next. I was just doing one at a time. Okay, so first I was dealing with my square identity, which is this part over here. Okay, so sine squared p plus cos squared p is equal to 1. And now I was going to do the second part. Okay, so sine p, and again, I can write sine q as cos p. So I'm going to write this as cos p is equal to 49 over 25. And now I can take the 1 over to the other side. So 2 sine p cos p is equal to 49 over 25 minus 1. So that's going to leave me with 2 sine p cos p, and 49 over 25 minus 1 is going to be 49 over 25 minus 25 over 25. Leaves me with 24 over 25. And 2 sine p cos p, according to, sorry, please can we mute? Thank you. So according
Yes, I've
to
muted
our,
them.
thank
Sorry.
you, no problem. According to our double angle formulae is going to be sine 2p. And there we go. We've got the value of sine 2p. All right, are there any questions? I would imagine there probably are with this question. Any questions? Anything you want me to clarify?
And take a screenshot so it can sink in.
Yes. So Howard, please can you repeat the part in orange? Okay. I'll show you where the marks will be. I would hope so, Malendle. Be a bit bad if I put this question up and I couldn't answer it. Hey, got foxed by my own question. Yes, Sinintlandla, it is a long question for a lot of marks, but that's often what it's like. I mean, there's a lot of working that needs to be done when you get to grade 11 and grade 12 for, all right. So if we think about it, what is necessary for us to be able to answer this question? Okay, those 5 marks. Well, first of all, we have to be able to square both sides, don't we? Okay, so squaring both sides has to have an accuracy mark. All right, we're not going to get marks in matric for foiling out brackets. The next thing that we're going to get marks for is for recognizing that sine q is cos p, or that sine squared q is cos squared p. So there has to be a mark for that. All right. Then there would have to be a mark for getting sine squared p plus cos squared p is equal to 1. There would have to be a mark, I would say another mark for writing this sine q in orange as cos p, because you need to get 2 sine p cos p. And how many marks is that? 1, 2, 3, 4. And then our last mark here would have to be on our answer. So yes, I agree. Maybe it could have been out of 6, but in a way they're being kind by making it out of 5, because if it's something that's very difficult for everybody, if people can't do the question, you lose 5 marks and not 6. What happened to the cos p? Cos p is sine q. Okay, so sine q was rewritten as cos p. If p plus q is 90, then sine q equals cos p. Okay, iPhone. All right. Okay, so look at the diagram. Okay, remember sine q and cos p are equal to the same thing. Right, they're equal to each other. Okay, because p plus q is 90. And if sine q equals cos p, then sine squared q will equal cos squared p. What? Kamogelo, is this the only method? Kamogelo? I cannot off the top of my head think of another way that you would do this particular question, because you'd have to start off with squaring both sides, and then you would have to manipulate that sine squared q into an angle in terms of p. So I can't think of anything else off the top of my head. This is how I would do it. Did you do something differently, Kamogelo? All right, well, I'll wait for Kamogelo to answer. Yes, okay. What you could do, Kamogelo, if you wanted to, is you could always send your answer to email, and then I can have a look at it for you if you want. Okay, so I'm just going to put my email out here again. Oops, it's not capital. There you go. So if you want to email it to me, I can have a look at what you've done and see whether that works. Okay, Kamogelo? All right, so we've got 15 minutes left. Let's do, cool. Let's do this question. All right, so they ask us to consider f of x equals sine x plus 25 cos 15 minus cos x plus 25 sine 15. Okay, and then they ask us to determine the general solution of f of x if it's equal to the tan of 165 degrees. Okay, so what do you think our first step should be? What do you think our first step should be, Matrix? Go for it, Lesedi. What would you do?
Hi, ma'am.
Hi, Lesedi.
Hi, ma'am. I'll change the sine x plus 25 to, I think we use a double angle formula.
Okay, why do you want to use a double angle formula?
Ma'am, to change the sine x plus 25 and the cos 15 to something smaller.
Okay, so you don't ever have to reduce angles that are already smaller than 90. What they want you to do, there we go, Trish. What they want you to do, Lesedi, is they want you to recognize that f of x is a compound angle. Can you see it's a sine of one angle, sine A cos B minus cos A sine B? Can you guys see that in f of x? Can you see that it's a sine compound angle? Do you see that? Okay. So that means that if we've got, let's write it down, we've got sine x plus 25 cos 15 minus cos x plus 25 sine 15. It's now going to be equal to the tan of 165. Oh, that's what you meant. Okay. All right. So compound angle as opposed to a double angle. Quite right. So if you remember, guys, sine keeps its sign. So they've given us the expansion. They want us to do the reversal of the expansion. So this is going to be the sine of angle A, which is x plus 25 plus angle B, which is going to be 15. Okay, so sine keeps its sign. Okay, and the tan of 165 is, I'm just going to write all of this out. Mind you, suppose we could write it in root form. It really doesn't matter. Actually, maybe that's better. Whoopsie. So it is equal to -2 plus root 3, which is a negative. Okay, so this gives us the sine of x plus 40 is equal to -2 plus root 3. Is everybody happy with that? Because it's a sine compound angle. So tell you what, just give me one seckie. Sorry, guys. Just go here. So there, go and have a look. Okay, so it's a sine compound angle. All right, so if it's sine A cos B plus cos A sine B, so we're looking at this one over here, Trish, aren't we? Then we should be adding A and B together, shouldn't we? Yes? Okay, so cos A plus B, there's a minus. Okay, but sine keeps its sign. All right, so that's what I always teach my matrix. Okay, so I'll just write it here for you on the side. Okay, Trish. So sine, so it should be sine theta, sine keeps its sign. Sine keeps its sign. Sine theta keeps its sign. Okay. So if this is, oh, sorry. That's, I hear I'm going, sine keeps its sign. Sine keeps its sign. That is a minus, isn't it? Sorry, Trish. You're quite right. Don't know why I'm being doof here. Sorry, guys. Trish is quite right. Sine keeps its sign. So this should be a minus. Okay, so that would be plus 10. Sorry, Trish, here I'm saying exactly it and then I'm not doing it. Okay, so sine keeps its sign. So beg your pardon, let's just go back to the other one. Sorry, we were looking at this. I beg your pardon. Okay, so sine A cos B minus cos A sine B. All right, so sine keeps its sign. Are we all happy with that? Sorry, I was just being silly. It's a negative here. So now we are ready to find our PAA. And what are you guys getting as your PAA? Matrix, have I lost you? Are you guys okay? Is everybody still there?
Are you guys, you can just ask questions. You can unmute and ask, or you can. Jimmy says, please repeat. No, that's a previous one.
Okay, why are you lost, Zoom user? What are you lost on? You need to be specific about what you're lost on. Okay, remember, Jimmy, a RA cannot be negative. It's got to be positive. We haven't got the reference angle yet, Zoom user. I'm still waiting for you guys to calculate it. Yes, the negative just tells us which quadrant we're in. That's quite right. So you should be getting a reference angle of 15,54 degrees. So -2 plus √3 is a negative number, negative 0,267. So you're not going to use the negative. So you can multiply that by -1 on the calculator. And then you can use that to put into. Okay, so just like we did up at the top here. Okay, remember we didn't use the minus when we calculated the 60. We worked out the cos of a half to get the 60 degrees as our PAA. So same story with this. We don't use the negative to get our PAA. Right, but our ratio is negative. So now we need to work in the quadrants in which sine x is negative. So again, our cos diagram and sine theta is negative in quadrants 3 and 4. So those are the quadrants that we are going to work in. So in quadrant number 3, our angle is x plus 10, and it's equal to 180 plus our PAA plus k times 360. So this would leave us with 185,54 plus k times 360. Or we'd be working in quadrant number 4. So then it would be x plus 10 is equal to 360 minus our PAA of 15,54 plus k times 360. Okay, so x would be equal to 334.46 plus k times 360. K is an element of the integers. Sorry, I think I made a mistake in the previous one. Sorry, this should, no, yes, I did. Sorry, this should be 154. Sorry. Sorry, guys. Long day. 154,46 because it would be 180. Yeah, man. I'm so stupid. I was right. 180 plus 15.54 minus 10. Oh, no, I was right the first time. Sorry, I'm second guessing myself now. Sorry, that is perfectly correct. There we go. Yes, you must, Sydney. I don't know what you see now. If you're getting a math error when you're putting something into a calculator, you could be forgetting to close a bracket. So unless I can actually see what it is that you're doing, it's a little bit difficult for me to give you guidance on that. What I can do, just give me 1 second. Where is my simulator? There it is.
Could it be that they've inserted the negative sign when they're
It could be. So what I'm going to do is hang on a second. I think I need to, oh, no. I think it's the screen sharing thing, new share. I think I need to say screen. Okay. So can you see the calculator? Can you guys see the calculator on screen?
We can see the screen.
You can see this. Okay. All right. So if you put in -2 plus √3, that gives you that negative number, right? But you don't want to use the negative to calculate the PAA. So just times it by -1, right? Because that's going to make it positive, right? And now we want the sign. So now we're going to say shift sign, pop in our PAA equals. There you go. Okay. Can you see that now, guys? A little bit better when I did it with the calculator on screen. Does that help? Okay. Oh, good. There we go. You were being lazy. I'm sure you weren't. Got it. Oh, good. Impelently. I'm so great. Okay. And then is everybody happy with why? So you ignore the negative, Jimmy, when you are calculating your PAA, your reference angle. You use the negative to work in the correct quadrants. Okay, so the sign of your ratio tells you which quadrant to work in. Okay, so you don't use the negative to calculate the PAA or the reference angle. Okay, because you want that to be positive. You want it to be an angle in the first quadrant. If you've got a negative angle, then you're not working in the first quadrant. You're not working with an acute angle. You're working with an angle in the fourth quadrant. Okay, -15.54 is the fourth quadrant. It's not the first quadrant. Okay, so we want to start in quadrant 1 with our PAA. Okay, Jimmy? All right, well, I hope that helped everybody else. Sorry, Trisha, I'm busy lecturing you going sign keeps its sign, and I was being silly and I didn't keep my sign. I hope the rest of it makes sense. Okay, everybody, please do the poll.
Yes, please.
No, Sydney, because you're just making your PAA, making your ratio positive to find your PAA. Okay, you're not actually solving the equation at that point. Okay, so if you have a look above, for example, when we were doing this question over here, okay, we ignored the negative and we just used the 1/2 to get our PAA of 60. We're just doing exactly the same thing here. We're ignoring the negative and we're working with a positive number to get the PAA.